Okay, hi and welcome to video notes 3.4 on solving multi-step inequalities. In this one, we've already seen a video where we did basics, but this time we're going to do multi-steps, which is going to include some addition, subtraction, multiplication, and division. With the last video, you should have noticed, or you should be familiar with one main concept, that solving, we're working with operations and linear inequalities, right, are the same operations as the linear equalities that we've been working with, except when we multiply and divide by a negative number. That's the only time it's different. So let's take a look at that, and then we'll see it in action. Okay, so if we multiply or divide by a negative number, again, with inequalities, then you flip or reverse the inequality to deal with it. And we've had an investigation that should have showed you why. Okay, again, let's just recall, we're going to use the exact same solving processes of reverse order of operation by inverse operation to solve these, except for when we hit that spot of a multiplication or division of a negative number. And then we flip our inequality and we continue on like we've done. So let's see that in action. Let's do this example here. All right, so it says solve and graph the solution to this inequality. Now remember, we're going to do addition and subtraction first and then multiplication and division. So looking at this one, I notice that I'm going to solve for a here, and I've got a term of positive 7 that's added on. So I'm going to go ahead and subtract that from both sides. I'm going to get 6a is greater than 12. Now notice, I am not flipping the sign. Because there's a negative does not mean I flip. Only with a multiplication and division of a negative do I do that. And you'll see in this scenario then, there isn't that case. Now I'm going to, since I've done the addition and subtraction, I'm going to deal with multiplication and division, which means divide by 6 on both sides. I find out a is greater than 6. So let's go ahead and make a number line for ourselves to graph this. And we'll grab some red here, and it's 6, so I'm going to put 0 somewhere over here. I'm going to get 2, 4, 6, 8, and we'll even throw a negative 2 over here for reference. All right, now we can graph our inequality. Our boundary then is at 6. I'm going to go ahead and note that this is not a greater than sign, not a greater than or equal to, so it's going to be an open 6 at our boundary 6, and then I'm going to say that our solutions are greater than our boundary. So I'm going to be graphing to the right. Okay, treated it just like it was an equality, and we did the exact same operations and then graphed. Remember, we've got lots of solutions though when we're done. It's not just 6, that's just our boundary to show us where all of the other solutions are. In this example, we should see a flipping. All right, so I'm going to grab my pen. Treat it just like normal. Our first step, our cleanup step, would deal with order of operations, meaning that we have to get this distributive property cleaned up and then our like terms combined as well. So I'm going to go ahead and distribute. So I'm going to get 2t plus 6 minus 3t is greater than or equal to 1. I'm going to combine my like terms, which I'll identify here. My t's are like terms, so let's start with those. So I'm going to end up combining those to a negative t plus 6 is greater than or equal to 1. Now we're going to start our solving by ROO by IO. So I'm going to go ahead and remove my addition and subtraction first, which is this 6. So I'm going to subtract 6 to both sides. I'm going to find out that negative t is greater than or equal to negative 5. We have to move that negative. Now you can see that this property is going to come into place. We are now multiplying or dividing, either way it doesn't matter. I'm going to go ahead and multiply my negative to remove that 1 there. So by multiplying that in, I'm going to switch my values first on my t and my constant. I'm going to switch those because that's what my negative 1 does. And at this point, I'm going to take and I'm going to even grab a different color. I'm going to flip my sign. That would be the appropriate time to flip your sign because we did multiply by a negative. So what we find out is that our solutions are less than or equal to 5. So let's go ahead and graph this then. I'm going to grab a nice dark line. Let's grab a color and label this up. So I got 5, so I'll put my 0 right about here. We'll do 1, 2, 3, 4, 5. We'll sneak a 6 on there and maybe even a negative 1 for reference. All right, let's graph and address our inequality. Our boundary is at 5, so let's go ahead and circle that on. I'm going to notice that it does have an equal sign, so it is included, so I'm going to darken that in. And I'm going to read it in reference to my solutions. My solutions then are less than or equal to my boundary. Being less than means I'm going to be shading to the left. And there is my graph that represents all the possible solutions for that inequality. So, quick review. Same operations as working with our equalities or our linear functions. The only difference is if there's a negative or multiplied or divided in that process. All right, thanks for watching. See you in class.